3. Started.
Okay, perfect. So my name is David Gonzalez. I'm going to be sharing some information about Kubernetes in the Cloud Platform with you. First of all, before starting, this is the meetup page where we actually organize these calls and these videos. So you can see that the meetup is called Kubernauts Worldwide Meetup. So if you haven't enrolled yet, please enroll because there's a lot of very valuable talks and videos about it. So I will recommend you to join here. Now let me share my presentation. Okay. Okay, so the name of my talk today is called Google Kubernetes Engine for Developers, which at the end of the day is Kubernetes for Developers. But before going into the deep, who am I? So I am David Gonzalez. Here is my Twitter handle. You can see my email here as well. As the email says, I work for a company called Nearform, which is a Node.js software consultancy, but we have de-specialized from Node.js, and now we do all types of DevOps, DevSecOps consultancy as well. So if your company is struggling with DevOps or security, we can help you with that. I am also a Google developer expert. I'm being a Google developer expert now for 2 years in a row, and I am the only one so far in Europe about the Google Kubernetes Engine, which is quite an honor for me. I'm also quite fond into Kubernetes. I actually became recently member of the Node.js security working group, so you can see I'm quite active in the community. But I am also an author, so I wrote 2 books about microservices. You can see one on the left, and another one about microservices in general, which is a very comprehensive course. But the one that is most interesting for today is implementing modern DevOps. This book went to the market just in October last year, and you can find it in Amazon and in the page of the publisher, PactPub. Also, ping me on Twitter if you want to give me some feedback or you want me to share some content about it, and I'll be more than happy to do it so. So, like as my talk said, we are gonna deep dive into Kubernetes for developers. But before I want to do a recap, and I have called it Software Development in 2017, the Apocalypse. It's not a coincidence that it's 2017. It's not an error. This is a phrase that I was joking with a colleague of mine last year about it because software engineering has been around for 60 odd years. We don't have any quality standards around. Like if you go to one company, what is good for them and for the next company, like we have embedded software in pretty much every complex system in the world. So a nuclear power plant is running software, hospital machinery is running software. So it's scary that we have put software everywhere, but we haven't managed to define what is a standard as considered as good and what is not. So unlike other industries, the teams in an IT company, they are created on horizontal slices from your company. So you belong to the developers team, you belong to the product owners team, but you don't belong to the team one which manages an application and delivers it to production. So this creates a compartmentalization of people in the company, which ends up being a problem because no one has the holistic view of the system. So a developer does not know how is the infrastructure, and an infrastructure guy does not know how the software is built. And in my opinion, this is quite when someone has the full view of the company, it helps a lot to speed up the development and deployment of applications. So one of the interesting comparisons that I hear around is that developers are brick stackers, and full respect to brick stackers, but if a brick stacker can stack five bridges in an hour, in 10 hours he will stack 50. And that's a really easy mathematical operation to make. With software is different. Like if a woman can deliver a baby in 9 months, 9 women won't be able to deliver a baby in 1 month. So this is the same with software developers. You cannot really measure what's the work for developers today and what impact it's going to have for tomorrow. And in general, decisions are made by people who have a very limited amount of information due to this. Sometimes not only very limited amount of information, but a very limited amount of knowledge. In general, the big problem that we can see in companies is that no one has the CEO knows what he wants to build, the project manager knows how to build it, the developers know what to build, and the operations guy knows what to deploy, but no one knows everything end to end. So it's a very limiting factor in the software world. So the enterprise software, the release cycles is pretty much months. So it's not rare to find a company which they only do one release every quarter. Change management is a horrendous word, but is probably familiar to all you. When you go to deploy something to production before go to the change board, or the short initials as is CAP, and they start asking you questions about how did you build this? Has this been QA'd? Has this been reviewed by security? Do you have a run book? Do you have a deployment guide? So you are producing a lot of documents that you really don't need for being successful deploying the software to production. It's only because the people who we charge of the board usually does not know what entails building and deploying software. So they are more managerial administrative people which haven't been close to software for years, and pretty much they have a very fuzzy vision of what's going on. So you try to build an Starship with Darth Vader, as you can see here. But what you end up building, or what you end up looking, is similar to this guy, which, by the way, is famous in Portland, in Oregon. He was interviewed a few weeks back on the local TV because like people goes to Portland to see him, and it's really funny. If you search in YouTube, there are quite videos about him, quite many videos about him and running the monocycle. So one of the problems to solve, one of the solutions for the problem of compartmentalization is microservices. So microservices are good, but they are also bad. As I said, my company is a consultancy company, and we specialize in Node.js, but also in microservices. We have a lot of people around who are quite relevant in the community that have been building microservices for years. And one trend that we can see, or I can pretty much see on my own view, is that microservices are mainstream. So some customers or some people goes to the microservice route because it's what is going on now around. And this is quite dangerous because I don't believe that microservices are for everyone. So you need to be very careful and very upskilled to develop and deliver microservices successfully. And another interesting thing that's why we are here is that microservices do not work without automation. So if someone is telling you that you are building a microservices system, which you are deploying by hand one by one, it's an anticipation to failure. It doesn't matter what you do, it's going to fail for sure. One thing of microservices is that they empower cross-functional teams. If you remember back in my slides, I was saying that an engineer belongs to the development team, and engineers belong to operations. But with microservices, what we want to do is build teams who can take ownership of the work. And this is summarized on the phrase, you build it, you run it, which is quite interesting. So any team is part of any team is composed of people who is able and capable of delivering the software from end to end. If you ever work for a startup, you have seen this pattern. Okay, so you are 3 or 4 people, and everything goes fast as it can be. You can deploy and deliver, you can build, deploy, and deliver software very, very quickly. Then you start growing, and things start getting very, very slow because it's what we call corporate inefficiency. The bigger the company is, the harder it is to orchestrate everything. So with this approach, what we are encouraging is small teams. So you have like 3 to 5 people in every team building and delivering microservices. Then how does this team look like? In my opinion, developers, DevOps, product owner, and QA are the sweet spot of the successful microservices for continuous delivery. Be aware that the ones that are in red here are usually people who are not considered, or well, actually QA can be quite technical, but are people who are not considered technical people. This is completely wrong. So in my opinion, from developers to QA should be business and technical people on the same place. So a developer needs to understand the business, and a product owner needs to understand technology under the product, because you are not going to be successful delivering microservices and delivering your system if you don't understand the full end-to-end. The goal here is understand everything that goes on in the system. They always come at a cost, and I'm talking about microservices. There is one operational overhead, which is what we are going to solve today, and also the organizational alignment, which is what we have just spoken about, how you divide your teams to maximize the delivery power. But the operations overhead is pretty much like if you have an application and takes 2 days to deploy it to production, or 1 day or 3 hours, 100 applications is going to take 100 times the amount of time that you use for deploying this one. The best way to solve that is, as I will see in a second, Kubernetes and other orchestration platforms, but this is an schema before going deep into the technicalities on how your company should be operating. You can see on the right the different microservices. So this is across, let's say, a triangle and this funny shape. And you can see that teams which are capable of doing everything are composed in the same structure. So you have 3 teams for 3 microservices, which it might not be true. You might have one team managing more than one, but you have to have a minimum organizational unit who is able to build, deploy, and run the service on a very close and local community. So as I was saying before, Kubernetes, and in this case, Google Container Engine, is coming to the rescue. It's all about the operational overhead. So you can see how this is my system, okay? So this is a system that I always use for demoing. You can see the GitHub repository here on the top. It's open source, you can play with it. It's very, very small, but just shows what's the power of Kubernetes in a system that everybody can understand no matter what. So what we do here is we have 3 microservices, and these 3 microservices are an API aggregator, and then 2 services, one that converts a timestamp that comes in the URL into a UTC date, and the other one that converts the same timestamp into the ISO date. They are both the same date, but in a different format. So you can see here, these are 3 different microservices, and they have to be deployed differently, and they have to be managed individually, one by one. So the problem with it is that now it seems very simple. If you go to talk to a product owner, CEO, or someone who is not technical, they will more than likely draw you this image. And this image looks simple and, can be as simple as this plane. So now the problem is, when you are a consultant, you need to make sure and validate that this is what your customer wants. So you can go to them and say, okay, so you want this, but what about all these capabilities on a system that, they are not drawn in your image, but we assume that you like? For example, high availability. What happens if the API aggregator goes down? And they will come back to you saying, no, it can never go down. High observability, it's in red because it's a quality from services that people usually omits, but in my opinion is the most important one, even more than high availability. High observability is that you are able to identify a problem in your production system almost on real time. So you are able to observe what is going on inside the system without any complication of having to SSH, having to look into tons of logs. So you want to get a message in your text saying, hey, there's a problem here. Then the next one is self-healing infrastructure. People usually love that. So my software is going to run in an infrastructure for sure. So when I give to a customer the chance to select, what do you prefer? Get a text at 3 a.m. in the morning saying, hey, your server is down, please do something. Or get a text at 3:30 in the morning saying, hey, your server was down, but by the way, I have rebuilt the infrastructure and redeployed the application, and now it's running perfectly without any human intervention. Probably the second, but that comes as a price. Auto scalability, that's an interesting one. So imagine the people who designed the system for updating the software that runs in the TVs, because like every single TV, it's running software no matter what. So the Earth is a globe and it's rotating. When it's 9 a.m. in the morning in Spain, it's like 3 p.m. or 5 p.m. or 2 p.m. in India. So one of the interesting things of this is that when you hit the time for updating on dense populated zones like New Delhi, I don't know, big cities in the States, Paris, London, you get hundreds of thousands of TVs calling back home saying, hey, is there any software update for me? There are many techniques to manage that, but one of the things that you can do at short term, if you didn't realize about this problem, is you can have your cluster on Kubernetes to auto-scale for as many hardware resources as you need. So what happens is, if at 3:30 p.m. TVs from Delhi are going to be hitting your server saying, hey, is there any update? What you do is at 3:29, scale your cluster up to 1,000 nodes, 900 nodes, whatever you need to cope with the demands. And then you have there a room to breathe and take a decision on how to fix the problem of dense populated areas. Extensibility. So I don't want to modify the running system, but I want to extend it. So I don't want to take a feature that I have developed and I have considered done to be able to modify it every now and again and keep changing things, because what you deliver and what you develop should be correct. So once you deliver it to production, it should be extended but not modified, and Kubernetes gives you that pretty much for free. Service discovery, I will demo you that in a second in live in a live code demo. And continuous delivery. So if you see this, I cannot just run my application without continuous delivery, because when I update the UTC date service, my full system will be down if I don't have a backup strategy. So nowadays, when you build a product from scratch, you need to almost account for continuous delivery as a given. Like if you go to a customer and tell them, oh yeah, you need to take down your system for 2 days for upgrading them, they will go and say, well, no, we need to find someone else who can do that continuously. And it's a reality. Like you cannot build a system now without having continuous delivery on mind, because it's always the same concern I have. Like deployments are usually in big companies a big bang event, so everything stops, people deploy the software, and then everything comes back. In my opinion, when you build a system, you should be building it on a way that a deployment, it's a very routinary event, so everybody can deploy production at any time without breaking it, pretty much pain-free, and roll back without breaking anything as well with a click of a button, and I will show you that as well in a second. So our plane now looks more like this. So we have gone from a remote control plane with 3 or 4 button tops to the space shuttle with thousands of buttons or hundreds of buttons and few remote controls that we need to take into account, because the customer didn't know that they want until we show them our system. So what we can see now is this is how our system looks. It's exactly the same one, and this is how it looks from the Kubernetes point of view. So I don't know if you have any experience with Kubernetes, but you can look a bit about the API in internet, and you can see how the service is what allows you to expose a container into either the internal network or the external network. Replica set is the guy who makes sure that if a container goes down at 4 a.m., you don't get awakened to just restart a container. It will restart the container for you, and so on and so forth. So now I have been talking for too long, like around almost 20 minutes. What I'm going to do is I'm going to show you the code. So I'm going to keep this aside because I want to come back to this in a second. So this service here, just for simplification, has been built in GitHub. So I have all the code here that you can just go there, have a look, check, and play around. So the aggregator service is the one that pretty much contacts the backend. And let me just split this. The aggregator service is this one here, and is the one that contacts the backends and requests the change of the date from timestamp to whatever format they want. And the aggregator does not care what the system is. The only thing that they know is that I want a service called UTC date service to provide me with the UTC date for this. What is the IP of this? What is this? How to reach this? I don't care. I just want to reach a service called UTC date and send them a message to give me back what they have. So this is a very powerful concept, and it's called service discovery. So this allows me to even create a proxy on Kubernetes called UTC date service, and then call a third-party provider to do this service for me. So doing that with service discovery on this way, and it's plain HTTP allows me to completely decouple and play around with who is providing the service without changing the code for aggregator. Just making sure that the interface is clear. It's going to allow me to keep a steady state the development of aggregator and move around the UTC date and ISO date service on the way I want. So what I do here is very, very but a very, very simple Node.js code. So I have 2 endpoints, one for the UTC date, ISO date, and then once I get back the response from the 2 of them, just nesting the 2 callbacks, I reply to the interface saying that this is the UTC date and this is the ISO date. Now, if we go back into ISO date service, it's similar, but in this way, what happens is I receive a timestamp. What I do is I convert the timestamp to ISO string and then reply back. And same thing now with UTC date service. So I can come here, and instead of doing it to isostring, what I do is I convert it to isostring and just take the which is relevant for the UTC date. And that's about it. So now what I need to do is, you see from a developer view, this makes perfect sense because you have the 3 building blocks in building Node.js, and you don't care about how is the external world here. So now I need to define how I am going to communicate the 3 different blocks and how it's going to make sense all together. So what I have done is I have created the definitions for Kubernetes. So in this case, we have 2. One is the microservice. This one is my container. In this case, I have packed up and uploaded it to Google Cloud Platform under the name EUGC-IO Kubernetes.IO UTC Date Service. I'm going to tell it that this name is UTC Date Service. I'm going to label it as UTC Date Service, and I will come back to this labeling in a second. And I'm telling to Kubernetes that I'm deploying a deployment. So this is going to allow me to create here what we've seen before. This deployment entails the replicas of my container and the replica set. So I'm saying here that I just want one container running, but we will play with this in a second. Just I'm settling at here the infrastructure. Now, this is the deployment. This is the red boxes here. In this case, is UTC Date Service. So the red boxes in here and this blue box. But now I need to define how I'm going to communicate this service with the real world. So I have another file here, which is called UTC Date Service. And this one is JSON. The other one was YAML. So this is to show how flexible the API for Kubernetes is, that you can send a YAML or a JSON and it will take it no matter what. So what I'm doing now is I am creating a service, and you can see here this service. I'm using the version 1 of the Kubernetes API, and my name is called UTC Date Service. So what I'm doing here is I'm connecting the port 3001 of my service to the container port 3001. And this is the first match that we have, because if I go back into my microservice, I can see that we expose the port 3001. So this is kind of connecting the dots on Kubernetes. But now the most interesting part here is that I am using a selector to choose which pods or which containers I am going to select in my service to be exposed through my service. So I am telling, hey, give me back every single container that has the tag app with the value UTC Date Service. And if I go back to my microservice, I can see that my label is now app and UTC Date Service. So bingo, my service is going to go and say, everything that looks like UTC Date Service, please give it to me. Then if we go to the ISO Date Service, which is the twin brother of the UTC Date, we have the exact same. I have deployed here my service. In this case, it's called ISODate instead of UTC Date. This is the container that I have packed and uploaded to the Google Cloud Platform. I have labeled it as ISODate Service because this one is the ISODate Service. I want one replica running, and my name is ISODate Service, and I am deploying a deployment. Then what happens here is when I go to the service and this blue box here, I am exposing the port 3000 instead of the 3001, and there is a reason for this, which I will explain in a second. And my selector is now choosing all the containers, which is more pods than containers, with the ISODate service. So ISODate service selector is for pods. A pod is when I create my microservice, I am creating one container here, but I could potentially specify here more than one container, and they will be running inside the same pod. But just for simplification, not only for simplification but also for correctness, in production I usually tend to stick one container per pod, unless there is a very good justification for it, like for example a cache and the storage for it, or Nginx and some modules or similar. So now I have defined my two services here, and what I need to specify is how do I want this service to be seen from Kubernetes, and this is done by the type of service. The two of them are cluster IP. So this means that when I create my Kubernetes cluster, there is a network created inside Kubernetes for, this network is created for intra-cluster communication. So what I do here is deploy the software and then expose it to the internal network in a given IP inside the cluster. So if my UTC Date service has the IP 10.0.0.1, I can have here 10.0.1.0 or 10.0.1.1, and 10.0.1.2. So it's creating IPs in what we call the software-defined network, or SDN, which is the network created by Kubernetes for this. Then the only service that we are missing is the aggregator, and this is a bit special. So the definitions are the same. So I can just create here my aggregator container, push it to Google Cloud Platform, give it a name, give it a label, and expose my port. But then what happens is I am specifying in the service that this service is type load balancer. And the reason for that is because this is my user-facing service. So this user is the one responsible for this red box here, which is outside the cluster, and it's going to be replying to my requests via the HTTP interface. So I hope it's clear. This service here belongs to this one. What I'm saying now is connect the port 8080 from your container to the port 80 of my service. So in this case, what is going to happen is specifying load balancer. Kubernetes is going to go to Google Cloud Platform and say, hey, I have someone here asking me for a load balancer. Can you please provision it and give me back the IP? And then you are going to expose this to the real world or to the other world via a load balancer. So what I'm going to do now is I have my cluster created in Google Cloud Platform here. And you can see it's actually here. This is the dashboard of my cluster. Oh, that's a bit inconvenient. The first thing I'm going to do is I'm going to log in into the dashboard, so you can see all the things that are going on inside my cluster. In this case, there is one service that I have created before for testing, but there is only really what Kubernetes needs to be running. It's just Kubernetes. Then what I can see here is the deployments, which in this case there are none because I have deployed nothing yet. So we are going to proceed to deploy the 3 deployments. So if I go back to, let me change these.
David, could you please increase your font?
In the browser as well?
Yeah, a little bit that way. In the terminal. Yeah, great, thank you.
I think it's better now, yeah. Okay, so what I'm going to do first is I'm going to create the microservice in Kubernetes. First, I just fire it, and kubectl connects to the cluster and says the deployment has been created. That doesn't mean that it's successful, but means that if I refresh this page, I can see now that the deployment has been created, and the green dot here means that it's successful. So this has deployed the service in Kubernetes, but only the service, like the microservice running in the container. So in fairness, I can go inside the pod and I can see the logs of this pod. So it has been started. Okay, now I can do the same for the other 2. So I can apply isolate service, definitions, isolate YAML, and then the same for the UTC date. I have sent these workloads to my cluster, and now what I have here is hopefully 3 deployments, and you can see one is being deployed. Isolate service has been already deployed, and aggregator, I have deployed that before. The trick here is that everyone has its own pod running, but I don't have way to access these workflows from outside the cluster. So what I'm going to do now is I'm going to create the services. So I'm going to tell to Kubernetes to connect all the dots, so these lines here, to be able to fully operate my system. So the first thing I do is definitions. I create the service that I have shown you before. So the one that creates the load balancer in my infrastructure. So in this case, for the aggregator. But I can do the same now for isolate service. And same for UTC date service. So if I go back now, I have still the 3 deployments, but once I go to the services tab, I have the 3 of them. One is being created now, which is the aggregator. It takes longer because I have requested a load balancer in Google Cloud Platform. If I go into the networking section of Google Cloud Platform, I think it is load balancing. I can see my load balancer here being provisioned, and it's targeting 3 instances, which in this case are my 3 nodes of the cluster. So if you go to the cluster, what is happening here is I have 3 nodes, and my load balancer here in Google Cloud Platform is pointing to these 3 nodes in the cluster. So when I specify that I want a load balancer, what really happens is that the Kubernetes cluster exposes a port in every single node, and then the load balancer is configured to target this port. So it's not magic, it's just science. So now I have deployed the services. I have deployed the internal services and the external one. So you can see here the internal endpoints. So one of the things that happen as part of provisioning these services is that I have given them a name. So this name is registered in a DNS that you can see inside Kubernetes. And now whenever I try to resolve the name UTC date service, it's going to come back with the IP of my service, which in this case is this one. I haven't tried this before because I have seen that this has been added today, but let's try it and see if I can do it. So I'm going to try to resolve the name from inside the cluster, but I don't know if this is going to work. We have this command. No, ping. Yes. So we are in UTC date service. Now I am trying to hit the UTC date service. And you can see that has been resolved to an IP with a qualified name, which is isolated service default SBC cluster local. This is the name that Kubernetes gives to my my service, but the qualified name is isolated service. So it's the only thing I need for that. So, and same with the aggregator. So if I ping the aggregator, aggregator, I'm missing the T. No, I'm missing something. Oh, aggregator service, of course. So it has been resolved to the IP of the service. So now there is a big difference here. So this service has an internal name, but we have also exposed the load balancer, which is the IP is 35.193.174.220. And if I go to my load balancer, I don't know if I can see the IP or not, but for sure, this IP 35.193.174.220 is the same one as in my service inside Kubernetes. Now I click here. 404 not found. The reason for that is because I need to hit the URL, as you can see here, /dates/timestamp. So /dates/123.123.123. And now what happened is the aggregator has connected to the UTC date service inside the cluster and the ISO date service inside the cluster and gave me back the dates converted. So now this looks pretty simple because we have one instance of every service, but I'm sure that if you are professional developers, you have been in the situation where the load of your pods is like 70% or 80%, and you start failing requests because you know in this case is very low, but you can go up and stretch the problem that's you know the CPU goes to 90%. So what we are going to do now is we are going to go, for example, to aggregator, which is here, to my service, and I'm going to go from, hey, my front end is having problems. This editor sometimes fails. I'll do it on the terminal. It's here. I'm going to go from 1 replica to 3 replicas because I have a lot of demand of this service. So I'm going to deploy 2 more applications and see what's going on. Oops. What's happening here? did something. Here. Should be working now. Yes. So I have specified to deploy 3 replicas. So now if I go to the deployments, I can see that aggregator service has 2 or 3 running because it's orchestrating them. And now when I go inside, I can see that I have 3 pods for the aggregator service. 1, 2, 3. And that is the way to scale up the application on just one click with my load balancer, with my service. So I don't need to worry about exposing them because if you remember what I have explained before, when you define the service, I have defined that I'm going to select all the pods that contain this label. And all the pods that I have just created, all of them contain this label. So if I go into the service aggregator, I can go inside and see how this service is selected all the containers with this label. Now I can come back and say, okay, so 3 was probably too much. Now I'm going to just leave it on 2. And with one click, I have gone from 3 to 2 again, saving resources. And you can see that very easily on the interface in Kubernetes. So this is how you scale up your service, and now how you roll out a new version. So imagine that I have a new version of my application, which in this case is going to be very simple. I have just created my my new version of the application. So the first thing I need to do is rebuild the container. Now I need to move my project here, Kubernauts.IO. And the name of my container is aggregator, not aggregator service. This is going to rebuild my Docker container with the new version of my application here. So I have just added a new line here, which is going to say hello to us. Let me see if this takes too long. I will go for questions and answers. It shouldn't take too long, but it's in progress. So the interesting part of all this dashboard is that I can totally operate the Kubernetes dashboard from the terminal. I can go here and see everything. Let me just make this bigger. I am a very visual person, so I like to see what's going on around me. Even though I like a lot of terminal, but I want to be able to just see on a click how many deployments I have in my cluster. Do I need to increase the memory of my cluster? Do I need to do many other things? So it's really convenient for everyone in here, and particularly if you are a developer and you are not an operations guy, you might end up having problems with the terminal. Okay, so now I have successfully tagged my container. What I'm going to do now is push the container into the server. It should be quick because pretty much everything else exists in there. Okay, here it is. One thing I forgot is that I need to give it a new name. I don't need to, but I will give it a new name to make it more simple. So what I'm going to do is docker tag latest to v1.0. And so I have created a new version of my container, which is called v1.0. Now the only thing I need to specify is, instead of using latest here, you are going to use v1.0. Okay, so one thing I can specify here, which I did for simplicity, is I can say to Kubernetes, hey, never take more than one container at a time and never put back more than one container at a time. But in this case, Kubernetes is going to do whatever it considers important. So now what I do is kubectl apply -f definitions aggregator microservice. Oops. This is deploying the new service. So if I go here, you can see how this is being migrated over the new one. So it's keeping the old replica set, which is the one having my load balancer. So I want to be able to still work with the old application while the new one is being deployed, but it is working on deploying the new one. So it's downloading the container, it's deciding which node is going to run my containers, who has the most capacity, who has the least capacity. Kubernetes has something which is called beam packing. So they try to ensure the high availability on the minimum number of resources. So you can remove containers, you can remove nodes from your cluster if you are not using them. So you avoid the fragmentation problem, which used to be quite popular on the FAT32 file systems. But now it's just making sure that we optimize as much as we can. So this is actually here working. It takes a bit because it needs to pull the new container, but you can see now it's running the new one. So you have the two replica sets now running, and you have the pods now running. So you can see how now I have only 2 of them, which are less than a minute or a minute ago. And then the old ones that I deployed in the beginning of the demo is 12 minutes ago. So I can see how my system has been updated. And now if I try to pull this again, I get the new version of my application in production straight away. So that's everything I wanted to show to you. Thanks everyone for taking time off your Saturday and coming here. Please do not hesitate to contact me. My email is here, my Twitter handle is there, and I have created a repository on GitHub called AMA, which is the acronym for Ask Me Anything. So if you have any question, log an issue in there. I'm a very, very busy guy. I travel a lot, so it may take a few days to come back to you on an email or on an issue, but I always come back to everyone. Okay? So that's everything.
Thanks so much, David. Great presentation, not for newbies, but I think I myself learned a lot from you and learned how easy or complex it could be to deploy microservices on Kubernetes, and learn from you. And one question regarding your upcoming microservices for developer course. Could you please provide some information about that?
Yeah, so one of the things that I get a lot when I go to talks is exactly what I got here. Look, this is not a newbie talk, but we need to be able to reach this level to use Kubernetes. So it's really hard to deploy software in production reliable. So you need to know at the minimum what I show me here to be able to deploy your service. And people come back to me saying, hey, this is complex. This is going to take me a few weeks, if not months, to understand how Docker works, understand how Kubernetes works, set up a cluster, play around, and then I'll be more or less confident to deploy software to Kubernetes. So what I have done is, with the publisher of my book, they are creating 2 courses. One is basic DevOps, Ansible, and the things that you need to understand to do basic DevOps. The other one is basic Kubernetes, which is pretty much the content of my book made in a course, and it's easy to follow. Actually, the person who is creating the course in the publisher is a recent graduate, so we are making sure that it's for everyone. And also, I am creating one which is more advanced. It's oriented to companies, and it's going to be exactly the content of this talk, but made a very long course, like around 20 hours that I have in mind, where you just build the application step by step, deploy the application on VMs, see how hard it is, and then resolve all the pain points with Kubernetes. I will tweet about them once they are ready. It's going to take me another few weeks, but I will definitely tweet and give discount codes to everyone from Kubernauts.
Great, thank you very much. Where will the course be published?
So there is one course that will be published in Expertfy. I have signed a contract with them. They provide training to companies, and that's the one that I'm building. But the other two are going to be published in Udemy, Lynda, Coursera, all the platforms online. I will make sure to let you know which is the best place to get the course at the best price and at the best way.
Okay, thank you very much. So is there any other questions from any attendees? If yes, please write in the chat or unmute yourself. We'll be happy to answer to your questions.
Yep.
Okay, so if not, then I shared my screen with you. Thanks again, David, for your great presentation and knowing that we can learn a lot from you and your upcoming courses on microservices. And also, I recommend to have the book Implementing Modern DevOps. I was very excited last week as I got in touch with you and ordered the book, and it's really very, very great.
Thank you.
Very excited about that, and thank you again for your kind support. Okay, so please let me introduce, for those who don't know about our fundamental, very fundamental basic training labs, which takes place every 2 weeks. We had 2 weeks ago our third training. Here you can find the video. I'm not going to repeat myself. You can get the video here. That's the site where our video, the video was recorded. That is 4 hours long, and you need some time to go through the whole video. But if there is any questions, please join us on our Slack channel. So if you don't know the Slack channel URL, that's provided here. With this link, we're currently more than 600 guys and ladies on the Slack channel, not only myself, but also other CKAs, Certified Kubernetes Administrators. I think more than 30 people are currently on our Slack channel. Will help you with any questions. Good. Let's go back to the slides. That are the slides. For those who want to get started with Kubernetes, these slides, you can use it for by self-learning, right? So there are a lot of links here. How to install Minikube, for instance, in your local machine. How to use a local cluster with kubeadm Vagrant and get started on Google Compute Engine, Google Cloud Platform, and GKE, Google Kubernetes Engine. And perhaps one important thing, we use a lot of resources from Kubernetes in action, and also a lot of examples from Michael Hausenblas, from Michael who wrote the Kubernetes cookbook together with Sebastian, which I recommend to buy it, and use it for our upcoming trainings. Okay, the next trainings will be more advanced. Please, if you want to attend in 2 weeks, get prepared with the first video, which I showed you on YouTube, and let us know if something is unclear, and how we can help you by get started with Kubernetes. So that's from my side. There are some questions in the chat. Okay, any sessions for configuration from Prometheus and Grafana for monitoring? Good. We can provide a session for Grafana. I will take your question, Nicole. What exactly would you like to know about Grafana and Prometheus? Please write in our Slack so we can prepare a session about that. Hope it answers your question, or at least we know what. Okay, thank you very much. Good. Then thank you for joining. We had around 25, 26 people, which had some problems, as I saw, to with Blackboard Collaborate. But next time, I hope we can provide better video sharing and a session for you in 2 weeks. By the way, our next meetup, we have office hours every week on Monday, 7 p.m. set. If you have any questions and would like to cover any other topics, please let us know. Thank you very much. Have a nice day, evening, night, wherever you are, and see you soon. Thanks very much.